Very good, good morning. Welcome. Thank you very much for coming this morning. Thank you for taking time out of your busy schedules, and I hope you've got quite an action-packed morning for you. For anyone who doesn't know, my name's Jefferson Lynch. I'm the client director at Red Olive, and I'm going to be your host for the morning. Just a quick recap in terms of the agenda. It's quite pacey, so we'll start this in a few minutes' time with a talk from Les here, and that's going to be looking at big data in particular, and there'll be a short break, and then the second session we'll come on to, we'll be looking at predictive analytics. What can analytics do for your business? So we'll be looking at applications of the data that we talked about in the first part. Well, I'm really delighted to have Les with us this morning. So Les is based in, comes from North America. He's the director for big data analytic applications at IBM there. And although he's based in Toronto, he spends an awful lot of his time travelling around the world, educating people about big data. And so I'm particularly pleased because he's actually on his way back to Toronto later on today for Thanksgiving. So Les, I'm really glad that you're able to be with us, and at this point I'll hand over to you. Thanks very much.
Well, good morning, everybody, and thank you very much, Jefferson, for inviting me to join today. And welcome. Look forward to the next hour or so, just talking a little bit about big data and some of the experiences that I've come across and what some of our clients are doing, and hopefully we'll be able to touch on a few examples that that resonate with the industries that you're in. Just a little bit about myself. I've been with IBM for 23 years now, and I actually started back when DB2 on the distributed platform, version 1, was shipping on OS2. So I've been in the information management, data management space for that entire time, and it's just been a fascinating area to be in. My contact information is obviously here, and I've got business cards here, so if anything comes up after today's session, please don't hesitate to just reach out to me at any time and ask questions. We can have a dialogue or whatever is required. I do a bit of teaching as well. I'm very passionate about teaching, so right now I'm currently a professor at Seneca College, one of our colleges in Toronto, and very happy to be here with you. As we go through today, what I was planning on doing is spending the majority of time just talking about and sharing experiences in the big data space. Please feel free to ask any questions as we go. Don't have to wait till the end, not trying to be formal or anything, so if you hear anything or you have any questions or comments or anything to add, please feel free to speak up, because I always enjoy having a discussion or conversation as part of the presentation as well. And then what I'll do is spend the last 15-20 minutes or so and just going through. I do wear an IBM hat, so just go through a couple of the products that we use and that we're leading with at IBM, and that help satisfy the needs that we'll have gone through in the first part of the presentation. So, if that sounds all right to everybody, I'll get started. The first thing that's probably worth just starting with is that we're kind of entering, and we're actually in this era now of cognitive analytics, or cognitive systems era. And the reason it's called that is because we're really getting to the point where we're able to leverage systems that do speed of thought interactions with us on whatever topic it is that we're focused on. And I'm going to go through this in some examples, and I'll also explain why now. Because if we look at some of these examples, we'll definitely be saying, I would have loved to have that 15 years ago. Like, why today is this happening? But part of what is involved with being in the cognitive systems era is the ability to interact with us at the speed at which we would interact with one another, and to interact intelligently with the information that we have. And so real-time analytics is really a critical cornerstone of allowing us to be in this cognitive systems era. In the first part of this presentation, I'm not going to mention anything about IBM except for one exception. I do need to introduce the concept of Watson as part of a broader conversation here. But who remembers about 3 years ago when we did introduce IBM Watson? It was with the Jeopardy game, and we took on basically the top 2 Jeopardy champions, and Watson was actually able to defeat them. So let's just pause for a second and say, all right, well, that's wonderful. So IBM's invested in a set of technology that's going to win at primetime games. That's awesome, right? So why did we choose Jeopardy? Well, think about what Jeopardy is, right? Jeopardy is a game where the topics can be pretty much any topic, and the question and answer portion can pretty much be any part of that topic. So we have to be able to go through a vast amount of information, react quickly, and figure out on topic what is the right response. All right? And what was being leveraged here is primarily text data. So 3 years ago, when we did this, basically what we were doing is in 3 seconds going through 200 million pages of primarily text data in order to respond in a timely enough fashion to beat the competitors of this game. Now, why text data? Well, if we kind of drew a pie chart of all of what we can traditionally consider to be unstructured data, right? I mean, we have our structured data, and they're in traditional relational databases, and we know how to deal with that data for the most part, and that's fine. So, but what is true about our business is across the whole market is that about 75 to 80% of data is actually in what we traditionally consider unstructured form, right? Now, if you drew a pie chart of all of that data, right, the largest chunk of that pie would be text data and or data that's easily converted to text. Now, what do I mean by that? Well, think about audio data. How many times do you call a company and not hear that, and by the way, this conversation is going to be recorded for training purposes or whatever, right? Now, how many people here have a mobile device that they can now just talk into to send a text message? You talk to it, it converts it to text, and sends it off. So basically, audio and text combined is just text, and we can analyze that data. And so that's why we focused on this particular game with Watson, because we were tackling the biggest chunk of what's considered unstructured data, or the untapped data in our businesses. Now, at that time, may as well nail the question of, and by the way, why big data now? Because this is a great time to do it. At that time, in order to go through 200 million pages of data in 3 seconds or less to provide timely, kind of real-time, cognitive type responses to the questions that came up, the system would have filled this master bedroom, so probably about half the size of the room we're in right now. Now, today, that system is 24 times faster than it was 3 years ago when we won the Jeopardy game. So that's the first thing. So what does that mean? It means either I'm going through 200 million pages of text in about 0.15 seconds, or it means that I can go through 2.4 billion pages of text in 3 seconds, right? That's the 24x, all right? That's not a 24% improvement, that's 24x, 24 times, right? And the second thing is, the size of the system is the size of 3 pizza boxes, which are sitting on the corner of the bed there, all right? So that means this is not a technology that is only available to a few select large companies who have lots of money to spend. This can roll in underneath your desk, all right? It is available to companies of all sizes, and it is very accessible, and it's extremely fast. 2.4 billion pages of text in less than 3 seconds. That's the speed in which we talk with one another. I'll say something, you pause for a moment, you say something back, there's a 1.5 second pause there, right? The cognitive system is there. So, and the volume of data that we can go through in a very, very short period of time. So, that's the only thing I'm going to say about IBM for the whole first part of this presentation, but that is, so IBM introduced Watson at that time, and we focused on text. So the important point to take from that is text data and the types of data that we can convert to text data is extremely is an extremely valuable and high percentage part of the volume of data that we haven't traditionally had access to. Now, one of the other things that's happening in the era of big data and the cognitive systems era is that the definition of real-time warehousing is being redefined. Right? So traditionally, how did we define real-time warehousing? We defined it as reducing the latency between what happens in our systems of record, our OLTP systems. So I sold something, or someone went to the bank, ATM, whatever. Something happened in my business, right? And when that data found its way into my EDW, my enterprise data warehouse, or data marts, and I could perform analytics on it. And that whole trend started with, nightly batch updates, and then a few times a day, and then some people pushed that over and said, I want hourly updates, or even every 30-minute updates. And then we got into this whole sort of real-time analytics of kind of trickle feed. Some companies have established, as soon as something happens in the transactional side of my business, I want it to flow into my warehouse now so that it's part of what I'm analyzing. And we continually reduce that latency, and that's what we call the real-time warehousing trend, right? Well, let me give another example of big data. This is a retail company. So a friend of mine had downloaded a online coupon for a clothing store, and this store was in one of our malls in Toronto. And went off to the store, went in, found some clothes that she really liked, took it up to cash out, showed this online thing, and unfortunately, for this particular store, the staff on hand didn't know how to deal with this online coupon, right? So after conversation with the staff, whatever, it turned out that they apologized, but sorry, we're not going to be able to accept the coupon. All right, so this individual was frustrated, had wasted time going to the mall, left the clothes behind, and went out into the mall, got a cup of coffee, and tweeted her experience. Just put out on a tweet. Within 3 minutes of her doing that, a message came across saying, hey, we see that you're in the mall, and if you come downstairs and around the corner, you're just 100 feet from us, come take a look at what we have, and if you find anything you like, we'll honor our competitor's coupon. All right? So she said, well, that's kind of cool. All right, so downstairs she went, and she actually did find some things she liked. They honored the coupon, and at that moment, a competitor took market share away from one of the other companies in the same store. Now think about what happened there. Right? The first thing that happened is that it happened while she was in the store, and while she was in the mall, and while she was frustrated. Not a few hours later when she'd gone home and was making dinner for the kids or whatever. It was when she was literally a few steps away from the competition. Right? They captured that event and took market share away from their competition. Right? That is what's happening now with real-time analytics. Now, what's special about that example? The piece of data that was used and that analytics was performed on never touched any system of record. All right? So real-time analytics now says, what? It's not only looking real-time at what's going on in your systems of record, but there's also new sources of data that also require real-time analytics and to be included in that process in order to capture business opportunity. All right? So a really, really interesting example from a retail perspective. Now there's a lot of different data types that got involved there. Geospatial data, they had to validate, hey, yeah, she's actually in the mall still close by. It's actually the store in this mall, not a store in some other mall in some other city. And the timing, all right? And we're going to come back to that example in a little bit when we talk about some other aspects of big data. Now you might be saying, well, that's a really cool example. What does that have to do with a picture of a skier? So I'm online, and my sons and I like to go downhill skiing, and I'm booking a trip to Banff in Canada to take my son skiing. And as I'm doing this booking, that we go skiing every year, so I kind of log in and I start looking at, hey, what chalets are available, where do we want to go, and so on. And I'm getting, when we go to websites and stuff, you start getting marketing things thrown at you. And I'm getting customized marketing thrown at me, right? And that customized marketing is based off of who I'm known to be, right? So for instance, Les likes to go and when I'm on vacation, I like to have a steak dinner or maybe catch some live music or something like that. So at the moment, when I'm thinking about booking my ski trip, I am being targeted for marketing on maybe equipment that I need, the types of things I like to spend my time doing outside of the ski slopes. So after the 6 hours of skiing and the half hour in the hot tub, then it's like, okay, what am I going to do, right? So I'm being targeted on how I'm going to spend my evenings at the chalet area in this town based on what I like to do, right? This is another example of, it's not just blind wide net marketing, it's targeted at me specifically. And there are a lot of examples of where we use social media combined with traditional information about our customer base to customize and target the marketing that we're doing. And that has a much higher, of course, hit ratio on purchases because I'm sitting at my computer at this time planning my trip. This isn't a coupon that turns up in my envelope or my package when I arrive and check in, and I've already sort of sorted out in my mind what I want to do on the 4 evenings that I'm going to be there. This is while I'm planning my trip. Timely, meaningful interaction with me as an individual consumer, not an en masse consumer. All right. So the second key point in all of this is the definition of real-time analytics is changing to include information that has never touched any of our systems of record. Okay? That's the redefinition that's going on. New sources of data, new sources of information, social being a key one of those, is now being incorporated into this real-time analytics processing. Now, if we take a look at kind of a cross-industry view, big data is really helping evolve every industry. Right? I've listed like 15 or so here. I'm going to go through a few more examples, but pretty much every industry, and I'm going to go through a few more examples. I think I've got a pretty good list of who's in the room, so hopefully I will hit some examples that touch each of your industries. But every industry is being evolved by this. So let's think about something else that's going on in Toronto right now. I'm not too sure if this is happening in London, but I've had so about a year ago, I had some people come by the house and they tore out the traditional water meter that was in my basement, and they replaced it with a device on the wall that transmits every 15 seconds how much water I'm using at home. And you might think, all right, well that's kind of cool. Now I know how much water you use every 15 seconds. Why would I care if you flush the toilet in the last 15 seconds? Well, think about what the telco companies have been doing for decades. I remember when I was growing up, we would wait till after 7 o'clock at night to call the grandparents because it was a long distance phone call and the rates per minute to talk were cheaper, right? Well, you can see a very clear return on investment for gas, electric, water, any kind of natural resource company to say, well, hey, there are peak usage times and I want to charge you more per liter of water or more per kilowatt of electricity if you're going to run your air conditioner at 3 o'clock in the afternoon, or you're going to decide you're going to do a load of laundry or run your dishwasher at 8 a.m. when 3 million people are trying to have a shower and get ready to go to school or work, right? So an environmental view of this would be, hey, we'd much rather you, run your dishwasher in the evening or during the night. And the other is just, hey, if that's a convenient time for you to do it, I want to charge more for you to do it at that time. So you can see that natural resource companies will start to move in that direction of charging you more for that resource at peak times, right? A, to discourage everybody putting their air conditioner on when it's like the hottest time of the day, and also to generally to get more money out of it, right? Now I'm absolutely certain it'll be marketed as, hey, if you use your if you run your dishwasher after 8 p.m. at night, we'll save you money, it'll be a lower rate. Meanwhile, that's the rate that'll stay constant and all the other rates will be higher. But it'll be marketed the way it is, but you can definitely see that there's a huge business value associated with that approach, right? So that's a really interesting example. Now, the infrastructure has to be there for all of that to work, so that, it's a staged process. And the other reason why that's a really interesting example is that the data being collected is 100% structured, all right? The data being collected by that device is a date time stamp, a meter ID, and a new reading, right? That's 100% structured data, but that's a big data problem. So one of the other points to get from the sort of first part of the presentation is, what is big data, right? It isn't just about social media, and it isn't just about mobile devices, and it isn't even just about unstructured data. It could just simply be a very high volume of the same data that you've been looking at all along, except before you were collecting it monthly, and now it's being collected every 15 seconds. And there's a business reason, a business value, a revenue generating value behind collecting the data with that frequency, just like that example there. If we take a look across other industries, the government's using big data for national defense is the obvious example. Looking at internet and purchase trends and so on, there's just a massively high volume of data that's being analyzed there to try and find patterns which would then indicate potential risks and so on. Healthcare. One of the things that's going on at Sick Kids Hospital in Toronto is they've been really focused on how to help predict newborn babies that would be at high risk of blood disease, and in particular blood infections and disease that would cause a fatality. And what they've started doing is, from the moment of birth, collecting massive amounts of data about the baby and what indications and so on. And I'm not a medical specialist, but they're collecting a massive amount of information, and they're able to then predict to say, hey, these babies are at higher risk of having some form of blood poisoning and so on, and then they proactively, before any symptoms have shown, start treating that condition. And they've actually been able to save lives, a significant number of them, statistically, from doing this. And that's a great cause. And it's an example of, this has nothing to do with retail and social media and mobile devices and so on, but it has everything to do with going through a high volume of data and a high volume of traditionally unstructured kinds of data and performing real-time analytics on it to make predictions and take action on where there's a high probability of risk. So I always find that that's a really nice example. Banking and insurance.
Sorry, Les.
Yeah,
in the spirit of keeping the conversation going to and fro, that last example that you gave sounds great. I thought you were going to say something, maybe you didn't, maybe I drifted off briefly. I thought you were going to say something along the lines of resource might be allocated to areas where the most at risk babies are within a hospital, within a NHS structure, which would be great. And what springs to mind is the almost inevitability that there'll be a baby somewhere who is not captured by the statistics and falls foul of this reallocation of resource to somewhere else. That example gets into the media, and people start complaining that the statisticians and and the data people moved this apparatus away from my child and it died? And the answer would be, from our perspective, would be, well, statistically, we've done the right thing. We've saved more babies than have suffered. And that's the on-paper response.
Right.
So it's a very open question. What is the response of the data community to those unfortunate examples of outliers that may have fallen foul of all the great science that we've done?
Yeah, no, and I think you bring up a very interesting point, and I'm going to jump to a different example now because of that question, but I guess a few responses. So one of the things about the blood treatment is that it wasn't necessarily a reallocation of mass amounts of equipment, but it was more of a proactive treatment. So, but
in another example, it might have been mine.
Absolutely. And one of the things that I'll say that Sick Kids has been good about doing is publicizing the fact, showing the stats to say, here's how many, post-birth deaths we had previously, per month, per year, whatever, because of this, and now here's where it is. It's not zero, right? But I you get into, so anything to do with medical care, there's always individuals who are going to fall through this. That's just natural. Canada, like the UK, has a primarily socially based medical system, and you can never get it 100% right. So all I can say is Sick Kids has been pretty good about getting in front of any exceptions by just saying, we've gone from 100 to 5. It's unfortunate that there's still 5, but look at the 95, right? Kind of getting in front of that. So I'd say that's one thing. But you're absolutely correct. So as long as the overall trend's heading in the right direction, I think you've got a good news story. But anything to do with healthcare is never going to be 100%, and I think that's something that we'll always struggle with. So I'm not too sure if I'm actually answering your question. All I can say is Sick Kids have been pretty good about publicizing the good news before anybody starts poking at the individual pieces of bad news. So
I mean, I wouldn't be confident that there is a proper answer to that challenge for those parents that may fall foul. I don't think there is an answer. If you reduce the overall, bad events, then you've done a good thing.
That's right. The good news is less of them in the company.
I wasn't expecting you to give the answer because actually I don't think there is one.
No,
but
it's good news when there's less parents in that situation. But I don't know if we'll ever hit zero. Now, the allocation of resources is actually a really neat example. NYPD, the New York Police Department, has started using many indicators and a kind of a big data application to predict where crime is likely to occur, who likely culprits might be, types of crime, and so on, and have actually used this predictive analytics to redeploy resources and try and prevent crimes. And they've actually been successful at reducing things like robberies and drug-related crimes, and even part of the attribution to the massive drop in the murder rates that have occurred from. So if you go back a couple decades, New York City was over 2,000 murders a year, and they went below 400 about 4 or 5 years ago, and thought that was they had done an amazing job. And part of how they accomplished that was this sort of predictive analytics on where's crime going to occur, and then they would actually deploy. So one of the things they did across New York City altogether was much more visual, uniformed policing, and in particular where that policing occurred was driven from things like these predictive analytics of this massive volume of data and indicators and trends and so on, and that has absolutely been part of the success there as well. Now, does that mean, to go back to your point, no crime has occurred in other places? In particular, there might even be a small increase in crime that has occurred in areas where they've redeployed resources from. But the overall statistics for the city have all gone significantly in the right direction, which is a good thing. So So that would be an example of where it's actually being used for resource redeployment, and we all know that, well, if you're a police officer, you can't be in two places at once. If I'm over there trying to proactively prevent crime, I'm not over somewhere else where maybe something else is happening, and it's a trade-off. So really good example of exactly, but we have our stats, and you know, if the murder rates are dropping, and the robberies are dropping, and violent crimes are dropping, and gun crimes are dropping, and everything else, we're heading in the right direction. Right, and again, it's a great example of, and we'll never hit zero. So,
sorry,
yeah.
I'm from the Met. We've done it here in London as well. So we use predictive analytics, not for violent crime, but for burglary in particular. Doing that, being able to predict within 15 minutes of where we predict it is likely that we will see a secondary offence. So using that to direct officers.
Oh no, that's a really good point. Once an offense has occurred, what's likely going to happen next? I guess even excellent point. Yes, I had heard that about New York as well. So, are you able to share any kind of like? And here's we've seen a 50% drop.
We've seen a big drop in burglary. Unfortunately, we didn't do it on its own, so we didn't do it as a control sample. We did a whole load of other activity as well. But our burglary rate fell last winter by almost 25-30%. So a huge drop in burglary.
That's awesome.
Really good.
That's great. And you would attribute this as part of what contributed to that. Excellent. All right, great to hear that. Banking and insurance. There's the biggest, and this actually gets into medical care as well. But the biggest growing area of big data applications in these areas are fraud detection. So where is something being misused, and where is there malintent going on? A little bit different with healthcare than banking and insurance, but very similar algorithms behind the scenes that are pumping out anomalies that say, hey, that doesn't look right. But one example, so I think we'd all get the fraud piece, but one really cool example I've been working on with a client is thinking about what people are doing now as they're looking for competitive rates. So I have 2 teenage sons, and they're starting to drive, and I suspect that it's the same here. But male teenagers get particularly impacted by insurance rates, you know, as they start joining your insurance policy. So you go out, and you know, whether you're renewing your home insurance or car insurance or whatever, I started leveraging social media and say, okay, what are other people paying, right? And you get a very quick view of, wow, you know, so and so is paying this, getting this rate with such and such a broker or company or so on. And so insurance companies realize this is what people are starting to do, and they actually have huge access to a wide volume of people. This isn't word of mouth anymore. I can basically poll 1 million people in Toronto very easily on social media, and, you know, just share an experience and see what comes back, right? And this company's putting in a system that basically does that. It looks across news source data to say, hey, what are the other rates that our competitors are providing, and then looking for proactively identifying their clients who are coming up for a renewal, and realizing, yeah, that rate's, you know, much higher than it should be, and practically saying, hey, we see you're coming up for a renewal. We'd like to offer you a discounted rate, and basically getting in front of losing that client before it happens. And that's a really good approach, because that would immediately save me the time of going out and trying to figure out, okay, how much money can I save if they came along and said, hey, you know, we're going to cut your rate by 25% because we see that, you know, you've been paying a premium rate and you've had good, you know, you haven't made any claims or whatever the case might be. And that basically keeps me from going out and proactively, you know, potentially leaving them as a consumer. So a lot of really interesting examples. Now I want to pause for a second. All the examples that I have given so far have been evolving those industries. There are also some disruptive forces that are appearing in the whole world of big data. Uber. How many people here have used Uber in London? A few? How many people have heard of Uber? All the hands go up? All right. So, I mean, it's amazing, right? So think about taxi companies, right? until we get to the world of Star Trek type teleportation, I'm going to need taxis. I need to get from point A to point B, and they do that for me, right? And population's growing. I've got the market cornered. I've got more demand. There's no alternative. I mean, if someone's going to take a taxi, of course, you've got the underground and you can own your own car, but and cycle and walk. But if you decide, hey, I'm not using my car and I'm going to go by car, taxi's the alternative. Then Uber comes along and says, well, hey, you know what? I'm going to help you get a great experience. And so now, instead of standing out in the rain, trying to find the one guy that has the light on his roof, I can now, from the comfort of my bar stool or restaurant seat, say, hey, I'm going to book a car. I know what the price is going to be. I can see where the car is and when it pulls up outside of the building. I can see who the driver is and what the ratings of that driver are, right? And all of this happens from the comfort and the dryness of my seat at the restaurant. We as consumers say, that's pretty cool. I like it. I'm going to use it, right? And all of a sudden now, taxi companies are kind of on their heels, which is if they don't step up to this new technical way, new technology and way of doing work and leveraging geospatial data and the fact that we have mobile devices and so on, they're not going to exist. And this is a company these are companies that would never have thought there would be any competition to their business, right? And we like it. And so there's a shift to the shift of power to the consumer. Some of the other examples I brought up are exactly like that as well. Like the power of being able to put a tweet out and then a competitor picking up on that, and I still get the discounts on my clothes, for instance, right? So we like that power in our hands. And so from a transportation perspective, taxi companies are going to have to step up or they're not going to exist, because that is a way in which we would much rather deal with that business. Who wants to stand out in the rain trying to flag a cab down when I can just be inside until it shows up, right? Netflix is another great example. Who here has heard of or watched the drama series House of Cards? All right. So think about how that show came about. Actually, at IBM's big conference last year, we had Kevin Spacey do one of our keynotes, and he basically walked through the whole process. This drama, political drama, came to television off of a dialogue with consumers on what kind of show would they like to see drama, okay, what kind of political drama, and it basically took input directly from viewers and said, okay, here's what viewers want, that's what we'll create. There was no pilot, there was no networks associated with that, yeah.
Can we just point out it was an English-British program a few years ago?
Oh, okay.
So it's actually a copy translated to the American.
Yeah, so,
okay. And that same process was followed for...
Was it the ITV or BBC one?
BBC
drama.
Okay.
Like 20 years ago.
Yeah.
Oh, well, I didn't know that. But
they
for the American House of Cards, they went and that's the same as The Office, by the way. I think the UK, the British Office is much better than the... It's good. Anyways, yeah, a lot of great TV ideas have come from here. But anyway, so what they did with the American version of House of Cards, though, is they built that drama based off of direct input from consumers and bypassed a lot of the stages that multi-billion-dollar organizations and segments of that industry have genuinely had control over, right? So again, that's a disruptive force and leveraging the shift of power to the consumer. So as we start to look at, as we kind of cut across these industries and so on, a lot of industries are evolving, but big data is bringing about big change, and it's going to cause companies that we would have looked at and said, well, they're not going to go anywhere, to simply not exist if they don't jump on the bandwagon of change. So, anyways, I hope that was kind of useful from the point of view of sort of stepping across multiple industries here and so on. Now, out of all of these examples, a few things should be apparent. So the first is there's 4 V's of big data, and you might have heard some of this before: volume, velocity, variety, and veracity. Now, volume, all right, I think we can all see is part of every example we've gone through. There's always a large volume of data, and hence the term big data. Never liked the term big data though, because it begs the question, well, what's little data, right? But anyways, high volume of data, dealing with petabytes or zettabytes of data in some cases when we're talking about social media, but data at scale is always a key component. Now, data in motion, right? The velocity of data. We think about the Twitter example, right? That the volume of tweets that are happening at any point in time, and then to find that one example or that one tweet that says, hey, I can take business action on this, right? So dealing with velocity of data gets into this conversation of analyzing data while it is still in motion. What does in motion mean? In motion means it's still on that conduit or that pipe, and you haven't landed the data in any repository in your organization yet. Well, why would you do that? Well, there's a couple of reasons why you would do that. One is the application demands it. Right? Think about in the financial space, stock tick data, right? Where the necessity of literally having access and analyzing information as soon as you can touch it makes a difference to the timeliness of, say, buy-sell decisions and investment decisions matters. That you make more money if you find out about the information a bit earlier, right? So some applications force a analysis of the data while it's still streaming. But another example with the Twitter data is that think of how many tweets you had to go through before you found something that you wanted to take business action on. And so you have this basic decision process being made as the data is flowing in, which is, do I not care or might I care? Okay, if you don't care, get rid of it, right? If you might care, then land it in a landing zone for further analytics, all right? If you land all the data there, A, it's very costly because you got to store it somewhere. But as soon as you land data in your organization, you got to worry about security and data lifecycle management and auditability and all this other stuff, right? There's a cost, and that's a cost that you don't want to incur for data that you know you're not going to care about. All right. So this concept of velocity of data and dealing with data while it's in motion has a couple of reasons why you would pay attention to that. Variety of data. I think in the examples we've gone through, we've done a good job. We've covered social media data. We've covered natural language processing, sentiment, and so on, and sensor data from a utility perspective. So data is in many forms now, but not always. Remember the utility example. While it was sensor data, it was 100% structured, right? So remember, big data doesn't always imply unstructured data. It just usually implies high volume of data. Now, veracity of data. This one we haven't talked about yet, and so we'll have one more example to kind of bring that to light. Forget big data. In your data warehouse environments, companies have always struggled with, okay, I've got all this data in my organization. How do I know I trust it? I look in 8 different systems and I get 9 different answers to the same question, right? So how trustworthy is the data, right? That has been in a struggle, an issue, a challenge with just traditional relational data that you're putting in an EDW and data marts and so on, right? And that's what gave birth to things like master data management and having a single version of the truth and so on. Now that I'm looking at new sources of data, that question, kind of raises its head onto the radar even more so. As I'm looking at social data, how do I know I trust this data? And there are capabilities out there that really help us bridge between the data that I know and trust, which is in my systems of record and my EDW and so on, with these new sources of data. And let me give you an example. We use like probabilistic and fuzzy type matching to connect identities. So my bank knows me. They know my name. They know my phone number, my last 5 addresses. They obviously know my current address because that's where my mortgage is. And they have a bunch of information about who I am, my email and my birth date and all that kind of good stuff. And then they want to say get a more of a 360-degree view of who I am. Now, part of this can help on the whole fraud detection side of things, and part of this can simply help with your relationship with your client base, right? So a 360-degree view of your clients is one of the growing areas in big data as well. So they're trying to say, okay, I know who Les King is. Now, who's Les King outside of my systems, right? So they're looking at things like Facebook and Twitter and other such sources. And they're trying to figure out, okay, so I see this, L King 1, 2, 3, 4 out there. How do I know that's me, right? Well, think about the information that you provided in 2 other places. One is in the social media things like Facebook. Well, what's on Facebook? You've got your birth date out there because this is the best way to be reminded of everybody's birthday, so you don't forget to wish them a happy birthday. You've got a network of people that usually includes family. You have where you went to high school and where you used to live so that long lost friends can find you and things like that. Now think about the security questions that you answer for your bank. So you can do online banking, right? Which is, all right, we want to validate this is really you. And you picked 5 security questions. What high school did you go to? Mother's maiden name? What was your what's your pet's name? All the same stuff that's sitting out on social media. So now all of a sudden I can go and start analyzing information and say, well, we've got a name that looks right, and we've got the same birth date, you live in the same city, you went to the same high school, same pet name, somebody's connected to your Facebook that has the same maiden name, information, and so on. All of a sudden it's like, okay, 99.7% chance these 2 people are the same people from my existing systems and social network, right? Now, it's not 100%, but I can make this connection through all of this sort of, what are the chances of being 2 different people with all of those things in common, right? So there are a lot of really neat technologies out there that really help us with the challenge of the veracity of data, particularly when leveraging these new data sources. And that's a key component, particularly when you're trying to leverage these new sources to get a better view of, 360-degree view of your clients. Now that identity matching can happen. Identity, I use the word identity specifically. People is a great example, but it could be businesses, business partners, suppliers, whatever. I mean, anything that's an identity that could have two sources of data. We can do this kind of fuzzy probabilistic matching. Now, how much you care about how accurate you are, very, very application specific. If you're doing fraud detection, you pretty much want to make sure you're talking about the same person. If you're trying to do a marketing campaign, well, that's okay. Then you can be a little less accurate and throw a wider net, right? So it's very application specific. How much you care about the veracity. So, few last points on kind of the market overall. The first is, as we deal with all of this, we've gone through lots of examples, a fit-for-purpose system methodology is absolutely the way the marketplace is going. All right? So a big data platform has a place for a landing zone for high volumes of data and unstructured data, and potentially including structured data. But it also has a place for a traditional relational data warehouse, right? There have been enterprise architects that saw the free Hadoop open source, neon sign and said, why am I paying for these expensive data warehouses anymore? We're going to just put everything over in Hadoop. All right, that has never once, in all of my experience, has been a winning approach. It has never worked, right? There are fit-for-purpose cases that make sense in Hadoop, and there are fit-for-purpose use cases that make sense there, and sometimes you're actually running queries and stuff that cut across those. We'll talk a little bit more about that. There's a component that deals with data in motion for some applications. right? There's components that deal with discovery of data that cut across all of this. So there is going to be, in your big data analytics platform, multiple systems that deal with different types of use cases. And by the way, I'm more than happy to send a copy of the presentations out. Those of you who are trying to film, photograph, whatever, I'll save you the trouble. You can get a copy of all of this. Now, as you're dealing with this, one thing that's true is as you roll in big data applications, you're going to need to worry about how do I move data around, how do I apply my security rules and regulatory compliance rules and data lifecycle management and auditability and all the same things you've had to deal with, high availability, disaster recovery, and so on. You now have a broader set of systems to think about with that. All right? But fit for purpose, multiple types of environments underneath the covers of your big data analytics platform is absolutely the way the marketplace is going. Whoops. The other thing that's happening is, and because of this, so growth in complexity as to the systems you're using, the other thing that's happening is companies are saying, well, all right, so I've got these new platforms, how do I leverage my existing skill base? I've invested in skills, I've invested in business analytic applications like Cognos and SPSS and MicroStrategy and Tableau and Business Objects and so on, SAS and whatever. How do I protect that investment? And so what vendors are trying to do is to help protect that investment. And I'm going to make 2 points on this. The first is, well, let's think about what all those applications do and where your skill base is. It's in something called SQL, right? Yes, there are developers and so on going off and they're learning new things like Mongo API and Jackal and Hive and writing Pig and so on. They're using new application programming paradigms. But the bottom line is that the vast majority of your investment for the last 2 or 3 decades is in SQL generating applications and SQL developers, because that's how you talked to your traditional relational warehouses and data marts and so on. SQL is what Cognos and SPSS and SAS and MicroStrategy, Tableau, that's what they produce, right? SQL's all over the place. So as you bring new parts to your big data platform into the environment, you want to be able to leverage that existing skill base to talk to these new sources of data, right? The other thing to think about is the ecosystem around your warehouse environment and your analytics environment all uses SQL as well, like workload management, security, auditability, ETL, ELT tooling. The way it talks to the data stores is SQL. So it's not even just your business analytic applications and your developers and end users, it's the whole ecosystem. Everything works with the traditional data sources using SQL. So that's the first thing. So why SQL for Hadoop? Because that's what you have. So the analogy I like to use is that of a hybrid car. And I kind of look at the architecture, right? These bright green boxes are kind of the new components. These darker green boxes are what we would traditionally have today in EDW, some physical and logical data marts, and ODSs and so on. You've got your operational systems. But now we're introducing this new kind of landing zone, place for doing queryable archives and some analytics. We're dealing with data in motion with real-time processing. And so what we want to do is create this data virtualization layer. And the way I look at this is a hybrid car, right? Today you have a car that's carbon-based, you go to the gas station, fill up with gas, and you have a driver's license that says, hey, I've invested the time to learn skills to drive this car. And you have API for that car, which is when I sit in the driver's seat, and I look at the dashboard and the pedals and so on, I know how to use the car, right? If you go and buy then a hybrid car, which has a second engine under the hood, an electric engine underneath the hood, you want to be able to leverage that driver's license, right? You don't want to have to learn something new, right? And you want to be able to leverage your API as you know it to be, which is when I hit the gas pedal, I really don't care what engine is firing, I just want the car to accelerate. And at the brake, same thing, whatever. Right? And so as you're evolving your big data, as you're evolving your traditional analytic infrastructure to a sort of logical data warehouse or a big data analytics ecosystem, you want to leverage your existing skill base. Your end users should be able to leverage their skills, your applications should still work, and they should also be able to take advantage of this new component. Which brings me to my last point on this part, which is, it is going back to what I said about the enterprise architects and things like that before with open source, is that while this is primarily open source, you should look at this as an evolution, a modernization of your existing analytic ecosystem, not a rip and replace. All right? You're leveraging what you have today and you're growing it. You're not tearing it out and putting something new in. It's not a rip and replace, it's an evolution, an augmentation, a modernization. Now, there are some workloads that will shift. Right? Today, you may have an EDW where you're performed with 7 years of historical data, but all of your analytics are really on the last 2 years, and you've got 5 years there because some regulatory body says you got to keep 7 years of data around. What we're seeing is a shift of what we'll call cold data from these traditional relational repositories over to a less expensive but still queryable archive. This is a great way to fund big data projects, right? So you take data you're not touching unless some audit comes up and you have to go back and look at something that happened 6 years ago, but you take data that you're not touching, and it's kind of called cold data, and you move it into a less expensive place, you save money, and it funds an evolution and that modernization. We've seen a lot of clients doing that.
So earlier you were saying trying to replace traditional structured data warehousing with Hadoop is kind of a bad idea.
And a rip and replace, yes. So individual use cases, okay. That's yeah.
Because then the slide says, well, 60% of people appear to be doing it, and then you're saying, well, actually, you can dump data out of the EDW into your data lake, and then you can use Hadoop SQL. So it kind of begs the question, well, why not then? Why can't you?
So the reason that that you want to keep some data here is generally tied around a couple of things. One is the performance requirements of the analytics that are going on, as well as the kind of the intensiveness of the analytics. And so there are more and faster analytics that can be performed because we've been maturing the optimizations of traditional relational environments for a long time, and things like Hadoop and Spark and so on are all very new. Now, Spark's a good jump in that direction because it's an in-memory processing engine. We'll get to that in a moment. But where things have generally landed is where you're performing the majority of your analytics on traditional relational sources, and you have to have certain reports ready for the CFO at 6 a.m. and things like that, where there's like a lot of performance requirements around them. Those are the workloads that you keep in the traditional relational environment.
This might be an over the coffee then, but if you can process billions of records in 3 seconds in something the size of a pizza box, he's saying that's still slower than a traditional EDW stack for that kind of question.
Because of the kinds of analytics that you're doing, right? So when you think about the text analytics, I'm looking for some keywords across a broad, set of data where most of it's going to be not there. On this side, I could be going through, 10 billion records for historical analysis of, what are my quarter-over-quarter results, and doing intense computations that affect every single row of data, right? So there's different kinds of analytics that are going on in both of those places, right? So that's what I'm saying. When you get to the data that you're not touching here, and only, except very rarely, the cold data, absolutely this is a great place for it, and you'll save money doing it. Right?
Thanks. Well, one more question, then I'm shut up.
No. Hey, I'm glad people are asking questions.
Is it going to eat EDW market eventually? Is it a question of time?
It all depends on technology, because the concept of an enterprise data warehouse may not go away. The underlying technologies may evolve. So you're still going to want an enterprise data warehouse, right? But The question is, so for instance, if we
Yeah, but
take a look...
is that just going to be a ring-fenced part of a data lake and just looks like an EDW in future?
Sure, you want something that looks and smells and behaves like an EDW. That part of the question you can swap. Right. Let me address the technology piece when I get into Spark in a little bit, and talk about what we're seeing from a technical trend perspective. Because the underlying engine on how all that works, that's going to evolve, but you're still going to want the EDW. So that would be the beginning of my answer. Okay. So, any questions on the whole market thing? I'm about to switch gears now, just like the last 20 minutes or so. I'm going to just share, how IBM has been able to what products and technologies we're leveraging, which will actually allow us to just dig one layer deeper on the technology, so you can kind of see how a lot of this is happening. And as I'm talking, I'll map back to some of the examples we talked about. Yes.
So, we're from the media here in the Daily Telegraph, and one thing on here, in data in motion, we're very interested in unknown people reading the website. But it's not so much a question, it's more of a dilemma we have, I guess, that there's more and more legislation coming in, isn't there, around going in incognito and protecting consumers from all of this data analysis. And I guess we're in this dilemma of, do we invest a lot of money in trying to analyse unknown users and what they're doing, and then in a year's time with legislation and browser applications, it then becomes irrelevant because everyone's in incognito and you can't see what people are doing because they're masking their activity.
Yeah, so excellent question, and I'll give you my opinion, and then I'll share an analogy which I think kind of backs it up. But who really knows exactly what's going to happen? So excellent question. Should we invest in all of this because eventually privacy laws and other things are going to kind of put a stop to it? Well, yes, governments. So two things. One, technology and innovation is moving at an order of magnitude faster than government policy. So one thing that's true is, in a lot of ways, the genie's out of the bottle. Right? We're doing it, we've invested in it, and so on. Now, that doesn't change different laws from coming up, but you can never pull the genie all the way back in. So think about what's happened with like record companies and things like that. Napster, roll back 10 years, Napster and other distribution models came out for the distribution of music, and then some bands like Metallica and others took a stand against that, and then there was some legislation and Napster got shut down, and then but where did we land? We landed in a situation where I can pretty much go get any music I want online, but I have to pay a little bit for it. And if you look from a musician standpoint, that primary source of income that they used to have is not their primary source of income anymore, no matter what legislation was put in place. That bridge got crossed and there was no coming back, and so now they need to focus on revenue from touring and t-shirts and paraphernalia and so on, right? That industry was irrevocably changed, and there was no way to pull it back to where it was. So I believe that's what's going to happen with legislation and so on. There'll be a little bit of reining in, but for the most part, the genie's out of the bottle. We willingly share, not knowingly, I'm consciously using this word, willingly share information, not necessarily conscious or knowingly that we're doing it, and I'm not going to be able to stop people from doing that. When I turn my GPS thing on here, I'm broadcasting where that device is, and which generally means where I am. People are going to do that, right? So if I'm publicly making my information available, it's kind of hard to legislate that people can't use it because I voluntarily have done it, as an example. So there'll be some reining, there'll be some controls, there'll be some fences, there'll be some attempts, and in the end, we've entered a new era that we're not going to back up from. That's just my predictive view.
I guess that's what we're weighing up at the minute. I guess we're going to focus on people who are willing to share their data, because I guess we're saying we'll help you enjoy reading the news more by giving us information of what you like, I guess. Right. And we'll focus our attention on there, I suppose, as the decision as well.
So a lot of companies actually started this already. Think about how many times you go and you sign up for something or you buy something online, and then there's a little checkbox at the bottom which is, either checked or not checked, but it's in the reverse of what you probably want it to be, which says, is it okay if we share this information with marketing companies and blah, 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 whatever, right? A whole bunch of this other thing, and then you say, no, I don't want you to share, and you try and click it. The first time you forget to click it, you now have a company out there that has your information that you have given permission to share. As soon as you've done that once, you've let your information out with your permission. So, and none of us are going to be, thorough enough to not miss that once, right? So, I just don't know how you reverse the process. Okay, any other questions? Was that interesting, first of all? Did everybody get a few tidbits out of that? So if I kind of summarize, think fit for purpose, remember the 4 V's of big data, remember its evolution, modernization of your environment, not, a rip and replace. And big data is affecting every industry, and it's actually becoming a disruptive force in some. So if you're kind of thinking of, okay, what are the key points that I've tried to cover with some examples in color, those would be kind of the key points. So let's just drill one layer deeper now on the technology, and I'm going to use IBM as the example, but I'll also point out where other vendors have similar things. So on these operational systems, your systems of record, there is as part of this whole real-time analytics and never down and being able to use mobile devices to get at my apps anytime I want, 24 hours a day, there's a huge trend on the OLTP system side that says, I just can't have my applications down anymore. These maintenance windows don't work anymore. I can't be just down all night. We just don't work in a 12, 16-hour day from a business perspective or a 24-hour day. And so technologies are emerging that basically give you kind of clustered, built-in, high availability environments that are application transparent. If something happens, either planned or unplanned to any of the components of that system, the application is still running, right? So the applications don't see outages associated with planned outages like maintenance and running backups and things like that. They don't see outages with unplanned outages, even leveraging disaster recovery type capabilities, which is if we have a citywide power failure here, there's another system somewhere else that's picking up the workload. And they deal with flexible deployment and multi-tenancy and security and all that kind of ecosystem stuff that's required. If we take a look at our traditional environments, there are traditional warehouse and analytic environments, there are technologies such as in-memory and Columnar, which are providing massive accelerations. So this is going to come back to the question that was asked earlier. Massive accelerations to our analytic and reporting workloads. And so from an IBM DB2 perspective, we've called it Blue Acceleration, but SQL Server and Oracle and so on and Teradata have their own versions of these. But we're seeing an increase in simplicity, so you don't need performance objects like indexes and summary tables and so on anymore. And we're seeing performance gains in the area of 37x performance gains for analytic workloads. Now, think about what that means from a productivity perspective. If you had a workload that, say, takes an hour to run, now it's going to take less than a minute to run. Right? It's a massive performance gain, right? You're talking like from hours to minutes or even seconds. This is the kinds of performance gains that traditional relational models are bringing to the table, which new open source models have trouble catching up with because the bar continually moves. So back to what I was answering earlier, very performance sensitive applications can leverage this kind of capability from what was always the highest performing platform to start with, which is traditional relational, and open source components just, they're not there yet, right? And we're also able to help save you a ton of money with compression rates. So things like Blue Acceleration provides 10x compression. So if you have 10 terabytes of data, we'll probably only use a terabyte of disk to store that data, which is great. And think about how many places you have your data in your environment. You have backup images, high availability environments, disaster recovery environments, test and development environments, as well as your production environment. So if we can knock your storage costs down by 90%, that multiplies out by 6 or 7 times. Right? So massive gains in performance and technology enhancements in the traditional relational space are continually keeping that gap there between what open source can do and what traditional relational can do. And so for performance sensitive, very intense analytic type algorithms and so on, relational is still the best place to go. NoSQL is emerging as well. Now, NoSQL does not mean no SQL. It means not only SQL. So it's more than just SQL, not a replacement to SQL. Right? Very important point. So relational databases are looking at how you can integrate some of these new forms of data, which would be considered unstructured today, with your relational data. And the way we do this in DB2 is we give you native data stores for things like XML data, which is like a tree structure hierarchical data, JSON data, which kind of looks like this, has a structure to it. JSON is JavaScript object notation, and it is the primary format of data used in the interchange of information between mobile devices. So there is a, whoops, obviously I flipped the cable there a bit. There is a vast volume of JSON data out there. Then we have RDF, triple graph type data. Now, why NoSQL? You can use SQL to access this data, but you can also use things like the Mongo API for JSON and XQuery for XML data and Sparkle for things like RDF, triple graph, and so on. And traditional relational databases are supporting these APIs, so it's called not only SQL. So that's a trend that's going on. Analytic appliances, right? Bringing massive performance and capability with the simplicity of just roll it in, the simplicity of an iPod type deployment, right? There's been a huge growth over the last 10 years in warehouses being implemented as simple appliances. And so that the Pure Data System for Analytics, which is the company Netezza we bought, is IBM's particular appliance, but this is the same business model that Teradata has, for instance, that Oracle's trying to leverage with Oracle Exadata. And then we start seeing data stores come about that are focused on specific data types. So Cloudin is an acquisition that we did at IBM, and it focuses on JSON data. It is a native JSON data store, and it is focused on being a data store for that type of data if you have a pure JSON type application. If you're just dealing with mobile data, then Cloud is a really good way to go, and it has all the enterprise type characteristics that you need, like high availability and the ability to do data movement and advanced query capability and replication and so on. All right, so you've got a few things. You've got technologies. So in that traditional relational space, you've got the whole appliance curve going on. You have in-memory and columnar type technologies that are providing massive performance gains, and you have the emergence of NoSQL and non-relational data stores to focus on this new set of data types out there like JSON. And then there's this landing zone, the new component in the warehouse that we kind of call the logical data warehouse. Cloudera, Hortonworks, there's a bunch out there. AsterDB is what Teradata has had. And IBM has InfoSphere Big Insights. Version 4.1 is the latest. All of these options out there are based off of basically a common set of open source components. And that's what all those boxes in yellow are, the open source componentry. So you've got Embari for tooling, and you've got Hadoop using the HDFS file system, and we support GPFS as well, that allow you to MapReduce jobs. Yarn is basically the next evolution or version of MapReduce. Then you've got a bunch of languages that you can use to write MapReduce jobs like Pig, and you've got Spark now as an in-memory processing engine that can be used on top of Hadoop. You've got Scoop for data movement between Hadoop and non-Hadoop environments. So there's there's a lot of infrastructure that's coming out of these open source components. And it's the same open source, whether you go with Cloudera or Hortonworks or Big Insights or just use open source, it's kind of the same common underlying base, right? Then the value that we try and bring is, well, we know that as you roll big data applications into your tier 1 mission critical type logical data warehouse environment, you need to worry about things like high availability, disaster recovery, data governance and security, and basically these sort of enterprise type requirements, ETL and ELT and data movement and so on. And so you need some glue around the open source that says, all right, I can seamlessly fit this into my enterprise data warehouse and my overall warehouse ecosystem. A few areas that are just worth mentioning that are kind of really evolving. Spark, as I mentioned before, is basically a new in-memory processing engine for analytics. And this is open source, and it's a great technology that is making its way into, and it's not replacing, it's complementing Hadoop. They actually complement each other quite well. Hadoop has unlimited scalability, where Spark has limitations. Spark can deal with data in motion and batch, where Hadoop is just batch only. Spark is an in-memory processing engine, so it outperforms Hadoop. But there are, like I say, there are places where only Hadoop will work. And Spark, so this goes back to the question that you asked, which is, we're starting to see, and we're actually starting to work on, Spark is going to become another technical component inside traditional relational engines like DB2, right? Because it has a very fast and powerful and highly scalable processing engine that can add value, just as in-memory and columnar technologies have added value for analytic workloads. Spark provides another way for us to even perform faster. But it'll be an underlying technology in a traditional relational engine that continues to move that bar forward. SQL. There's a thing called, we talked about SQL earlier and the importance of being able to just leverage your existing skill base. And I just want to say a few words about Big SQL. So every vendor out there has a Big SQL implementation. And the way they implemented Big SQL is what really matters a lot. What we did is we took our DB2 MPP optimized SQL engine and put it inside of Big Insights. So you're actually using DB2 when you come into Big Insights with SQL, right? You can still come into Big Insights using other forms of programming. But SQL is the skill base we all have, and SQL is the language in which our business analytic applications talk. So this has had some massive advantages. Green means just works, right? So we ran the TPC-DS benchmark, which is an industry standard benchmark that Oracle, Teradata, SQL Server, we all understand. And we ran that with Big Insights, with our Hadoop platform. And we ran that benchmark beside Cloudera and beside Hortonworks with Hive. Each one of these 99 queries is a typical analytic query that a product like Cognos, SPSS, Tableau, Business Objects MicroStrategy, and so on would generate. And green means that skill base just worked, right? You didn't need a new driver's license, didn't need to learn something new. It just all worked, right? Orange or yellow means, well, I had to do a whole bunch of recoding. I had to go get a new driver's license, but now I can drive my hybrid car and get to where I want to go. And red means you can go and reskill all you want, you just simply can't get that new hybrid car to go from point A to point B. So as you are assessing big SQL engines and looking at how to leverage your existing skill base and protect your existing investment, every vendor's going to say, hey, yeah, we support big SQL and we support SQL coming into Hadoop, but you actually want the SQL to all work. All right, so make sure you assess that not only from a functionality perspective, but also from a performance and a scalability perspective, lower is better, right? So in 48 minutes, where we were able to run all 99 queries, right? In 3 hours and 4.5 hours, some subset of the queries were able to run with other implementations. The data virtualization layer that helps us protect applications from this increased complexity. We all know that everybody has environments that are heterogeneous. You've got some IBM, you've got some Oracle or Teradata or Microsoft SQL Server and so on. Federation capabilities for connecting and querying, Scoop and DataWorks for moving data, and technologies that help you manage across seamlessly this entire environment are all part of what's being invested in from an IBM perspective, as well as other vendors. Some of this leverage open source components like Scoop, and some of this are capabilities that we've had for a long time, like Federation, which allows you to get data from Oracle or Teradata or Sybase or SQL Server, but it all looks like it's coming from the same location. It all looks like you're just talking to a single database, but in fact you're grabbing data from all sorts of different locations. And now that includes Hadoop-based platforms. Infosphere streams for that data in motion. Right? So the ability to ingest data, work with it, and then decide what subsets of it you want to actually harden into a data store. You can take actions, which could include doing nothing, right, on data you don't care about. And it can include making analytic decisions on data you do care about, or landing data into a Hadoop-based platform, for instance, for data you might care about. And that's basically what we have Infosphere streams that lets you deal with that data in motion. And then information integration and governance. I talked about that ability for connecting between the data you have and these new sources of data with the identity capability. There's a product called Big Match. It's a subset of our master data management portfolio. And no matter what, you're going to need to worry about things like, your security rules, your encryption, data quality, being able to have data lifecycle management, auditability, monitoring, and so on. You need to be able to do this across these new sources of data. And so you want a common tool set to do all of that. You don't want to have to, again, learn something new. So the ability to leverage your existing ETL tools, your existing data governance tools, your existing security tools, and your existing discovery tools to understand these new sources, the veracity of these new sources of data, are all very important components to consider as you're doing this modernization. And then, of course, sitting on top of all of this are our business analytic applications. And in IBM, we have Cognos, SPSS, and TM1 that all work on a common collaboration, metadata layer, and workspace across the, and because these are all SQL generating tools, they can leverage that technology I talked about that protects the, it leverages that data virtualization layer and leverages the SQL compatibility that we have between these new Hadoop-based components and traditional relational. And then last but not least, deploy it however you like. There's a whole movement towards off-premise cloud-type deployments, and there's still lots of companies that have security or regulatory reasons why they want to make sure the data stays on-premise. And if you're on-premise, you have a choice between customized deployments or rolling in an appliance. But everything we've talked about here today, you've got the choices between, off-premise, basically outsourcing the platform and the infrastructure to save yourself the work, and having an off-premise cloud type environment, or on-premise deployments in either customizable or appliance-like form factors. All right. And that brings me to the end of the presentation. Any questions? Was that useful? Did I cover what you were hoping to hear in this presentation? Okay, well then thank you very much. I really appreciate the questions, the conversations, and so on. I'll be here for the rest of the morning. And feel free to grab me, ask questions. I've got business cards here if anybody wants to reach out to me, and also I'll make sure from Jefferson you'll get a copy of the presentation, which also has my contact information in it. So thank you very much and enjoy the rest of your day.
Well, thank you very much, Les. I think there's one very practical thing I've taken from that, right from your example near the start, the Twitter example. I think we need to do be doing some work with John Lewis, and I need to hang around in some malls, and I hope we can get some good free homework out of it. But that's probably the thing I need to take. So, thank you very much. So, just against the agenda, we're running about 10 minutes behind. If I could, we're going to take a break now. Loose dots and coffee and things outside. Why don't we start again at 10 to? So that's about